Okay, good morning everyone. So myself Devabroto Das from Dumka Engineering College. Today we will take the subject process instrumentation and control.
Am I audible, Ajay? Am I audible? Please respond me. My whiteboard is visible. Okay, so let's continue. So we have discussed in our last classes, this is the process control industries, process control instrumentation, that is the level measurement. Okay, so for last classes, we have to discuss what is the level measurement, how it is possible, and what is the basic methods we have to use for the level measurement. Okay, so just recall them and then we have to continue our next part, that is a new part. So the level measurement. So you know that this level measurement, it is the basically one of the oldest measurement procedure in our process control industry. Okay. So this measurement of level measurement, you have to measure particular level of the any desired tank or any vessel or anything you have to when measuring for the level, what is the particular liquid, what is the level of the particular liquid. So at this moment, you have to use this the important procedure of the level measurement. So this level measurement, we have to classify it. Last classes we have to discuss. This is the direct method. Number two, it is the indirect method. Okay. So last class we have to broadly discuss the direct method. So this direct method, we have to classify it into three categories. Okay. You know that this direct method we have to classify it. This is the hook type level indicator. Number two, that is the side glass. And number three, it is the float type. Okay. So this is the basically direct method of the level measurement process. Okay. So last classes we have broadly discussed the type level indicator, side glass, and float type. So these three are the basically in the level measurement for the direct. Now we have to discuss another one, that is the indirect method. Okay. So indirect method, it is basically two types. One is the hydrostatic pressure type, and number two is the electrical method. Electrical methods. Okay. So these two process basically we have to classify it in our indirect method for the level measurement. Number one, hydrostatic pressure type, and number two, this is the electrical method. Okay, so first we have to consider hydrostatic, and then we have to measure the electrical method. So next page, this is the hydrostatic pressure type. So what is the hydrostatic process, or how it is basically measured for the level measurement method? So when a liquid, it is basically present on any tank at the rest exerts a force on the walls of the tank also. Okay, so this force of the liquid, it is basically known as the hydrostatic pressure, and this hydrostatic pressure, it is basically proportional to the depth of the liquid in the tank. Okay, so this pressure, this hydrostatic pressure method, it is basically used for the level measurement of a different procedure also. Okay, so I'm written that what is the principle of this process. This a liquid in a tank at rest exerts a force on the wall of the tank. This force in a liquid at rest is known as hydrostatic pressure. Okay, is it clear? So one such question it is also coming in your exam. What is hydrostatic pressure? So when a liquid in a tank is present at the rest exerts of a force in the walls also. Okay, so in the inside of the tank, so this force in a liquid at the rest, it is known as the hydrostatic pressure, and this pressure, and it is proportional to the depth, or this is the height of liquid in the tank. Okay, so this is the basic main principle of this process. This is the hydrostatic pressure type of level measurement. Okay, so when a liquid in a tank at rest exerts a force on the walls of the tank, and this force in a liquid at rest, it is known as the hydrostatic pressure, and this hydrostatic pressure, it is proportional to the depth or height of the liquid in the tank also. Okay, so this hydrostatic pressure, this is basically we have to use different methods or different parameters we have to use this for this hydrostatic pressure. Okay, so the types of hydrostatic pressure type. So these are the basically four processes are present. First one, pressure gauge method, pressure gauge method. Number 2, air bellows. Number 3, it is air purge system. Air purge system. And number 4, this is a liquid purge system. Okay, so this is the basically four type of process for the classification of the hydrostatic pressure test. Number 1, we have to use pressure gauge method. Number 2, air bellows method. Number 3 is air purge system, and number 4, that is the liquid purge system. Okay, is it clear, all of you? Jatin, is it clear? Jatin Kumar Jha, Kundan
Yes,
Kumar.
sir.
Okay.
Yes, sir.
Okay, thank you, Jatin. And any others? Is it clear up to this part?
Yes, sir.
Okay. So now we have to go first one, that is a pressure gauge method. Okay, this is the pressure gauge method. And this process is very, very important. One of the indirect method of label measurement. Okay, this mathematical expression, it is very, very important for your exam purpose. Pressure gauge method. So this process is basically one of the simplest method for measurement for the label measurement. Okay, so this is the simplest method used for liquid level measurement in an open tank. Okay, so if you measure the level measurement for the open of the tank, that is the open tank where the open reservoir or open tank is available. So this pressure gauge method, it is basically used for the simplest method for the level measurement. Okay, so this hydrostatic pressure of any liquid in an open tank is given by the equation. The equation is, that is, E is equal to rho into H into Hg. Okay, and another one, we have to accommodate this equation. This is H is equal to P by rho into Hg. So this is the basically main thing. This is the rho. Yes, this is a symbol of rho. Okay, so this is the basically main expression for the pressure gauge method. So the equation is, that is P equals to rho into H into H, and we have to calculate what is the height. Okay, that is the level, that is H equals to P by rho into H into H. Where P is the pressure in PSI unit. PSI, or we have to measure Newton per meter square. So this P is the basically pressure of the liquid. What type of liquid you have to use it and what is the pressure inside the tank. Rho, what is rho? Rho is the water density or any liquid you have to use it. So this liquid density. Okay, this rho is the particular liquid you have to use in the tank. This is the density. And Sg is the specific gravity. Specific gravity. Okay, so this is the Sg is the specific gravity, and H is the height of liquid. Height of liquid. Okay, and basically it is measured either inch or meter. This is meter. Okay, so this is the basically expression for the pressure gauge method. Please remember these things also. So we know that equation P equal to H into rho into Sg. So when you have to use this measure for the height of the tank or height of the liquid level of the inside of the tank, this is H equals to P by rho into Sg, where P is the basically pressure and it is measured in the PSI unit, or sometimes you have to measure Newton per meter square. Rho is the basically liquid density or water density. Sg is the specific gravity, and H is the basically height of the liquid. Okay, inside the tank, and it is measured either it is meter or inch. Okay, so this is the basically process of pressure gauge method for the hydrostatic process. Okay, when another one, we have to go next page. So please remember this equation. This is very important. Next, this hydrostatic pressure of liquid in a closed tank or vessel is given by the equation. So previously we have to calculate for any open of the tank or open reservoir. Okay, so when you have to any measure for the closed tank or vessel, so this equation you have to use this. This is P equals to rho into H into Sg. This is same plus external pressure on liquid. Okay, so this is the basically when you have to measure any closed tank or vessel for the level measurement or using the method of hydrostatic pressure method. So this is the equation P equals to rho into H into S. Okay, plus external pressure on the liquid. So you have to know this is the pressure, rho is the basically liquid of the density. Okay, and H is the basically height of the liquid, H is the specific gravity. So this is the basic procedure. So this pressure measured at the bottom of the tank. Okay, it continuing a liquid, it is known as the density, and also this specific gravity, this Sg, it is basically directly proportional to the height of the liquid in the inside of the tank. So this is basically principle of the pressure gauge instrument for the liquid level measurement. Okay, so this is very important. Up to this part, it is clear, all of you? So basic advantage is it is basically one of the simplest method that means here no construction is very easily, and it is very easily you have to maintenance. Okay, but one of the disadvantages available for this method, this instrument must be mounted at same level of the minimum level of the tank. Okay, so this is the basically one of the little bit disadvantages available this pressure gauge method. Next we have to go, that is air below. Air bellows method. So this air bellows method are used for liquid level measurement where an indicator cannot be conventionally located at the specified datum line. Okay, so where you have to use is the air bellows method for the level measurement. This is the basically used for the liquid level measurement where an indicator, it cannot be conveniently located at the specified datum line. In this case, we have to use this the air bellows method. Okay, so I am drawing a little bit idea you have to given. So this is the basically reservoir or tank. Okay, this is the basically pressure indicator where we have to measure the different pressure. We have to connect it this part and another part we have to connect it this one. This is a one indicator we have to use this, and this is a rotating device, that is the one needles you have to present. Okay, and this is a one air bellows system, and the structure is this pattern, something like that. So this is fill for the air, and this is the tank where the liquid is present. Okay, so this is the liquid level. This is the tank. This is the bellows element. Okay, and this is a pressure indicator. So this is a basically figure of the flexible air bellows method. Okay, this is a flexible air bellows. So this air bellows method, it is basically used for the liquid level measurement method, where the indicator it cannot be conventionally located at the specified of the datum line, that is the tank level also. So you have to use this pressure of the air, that is a bellows system. You have to usually measure the liquid level of the inside of the tank. Okay, is it okay, all of you? Jatin, it is clear?
Yes, sir.
Okay. Next, that is the air purge system. So this process is little bit, it is a heavier process for the level measurement system. So sometimes it is called the bubble tube. So another name is, that is not bubble, that is a bubbler tube also. So this air purge system, it is basically most of the popular system in our hydrostatic pressure type of liquid level measurement. Okay, so this air purge system is one of the most popular hydrostatic pressure type of liquid level measuring system. Okay, so it has a different apparatus we have to use this in this air purge system. This is the pressure indicator is available, which is record the basically inside of the pressure, and we have to attach the valve system, and one is the bulbar tank we have to use this, and we have to uses this process in the open tank or open vessel. It is also available. Okay. And another one, this is a liquid purge system. So when a air purge system it is unsuitable for any of the cause. Okay, so that means the air bubbling through the liquid, it is basically interface, it is not properly work, and what is the basically environmental errors is coming. So at that moment you have to use this the another one liquid purge system. Using this liquid purge system, you have to use for the pressure of the particular liquid. So that's why it is called the liquid purge system for the level measurement. So up to this part, we have to consider for the this first one, that is a hydrostatic pressure type. Okay. Another one, that is the electrical method. This is the electrical methods. This electrical methods of the liquid level measurement, we have to broadly use this in our process control industry. And it is basically classified into two categories. One is the capacitance level indicator, and Number two, radiation level detector. Okay, so these two type of level indicator we have to use as our indirect method. This is the electrical methods of the level measurement method. That is the capacitance level indicators, and number two, that is the radiation level detectors. So first we have to discuss the capacitance level indicators. So the principle of operation of capacitance level indicator is based upon the based upon the familiar capacitance equation of a parallel plate capacitor given by, this is the expression that is C equal to K into A by D. Okay, so this is the main expression for the capacitance level indicator for the level measurement, where C is the capacitance in farad, K is the dielectric constant, and A is the area of, and which is basically it is a measure for the meter square, and D is the distance between two plates, between two plates, and it is basically in the meter. Okay, so this is very important for the capacitance level indicators method. Okay, so what is the principle of this capacitance level indicators method? The principal operation of this capacitance level indicator, it is based upon the familiar for the capacitance equation for the parallel plate capacitor source, and it is given that is C equal to K into A by D, where C is the capacitance, it is in farad, K is the basically dielectric constant, A is the area of the plate, and it is measured in the meter square, and D is the basically distance between two plates in meters. Okay, is it okay, all of you? Okay, so next it is, what is the advantage? Okay, what is the advantage of this capacitance level indicator method? And this method, it is very important, this capacitance type of level indicator for the level measurement. Number one advantage, it is very useful in a small system. It is very useful in a small system. Number two, it is very sensitive. Very sensitive. So that's why this is you have to given the result. That is the accuracy is very much high. Okay, because when the particular a short level or short distance it is changes, so that means it is little bit any changes or in the level, so it is basically recorded. So it is very sensitive. Number third, there are no moving parts. There are no moving part exposed to the fluid. Okay, so in this system, there are no moving part. That means anyone losses is very much low, and it is suitable for continuous indication. Indication and or control. Okay, and number 5, it is good for use with different type of slurry. And last, number 6, probe materials for most corrosive fluids are available. So this is the basically advantages of the capacitive type of level indicators method. So that's why we have to broadly use in our process control industries for the level measurement method. Okay. So it is very useful for a small system. Number 2, it is very sensitive. So that means the any little bit is changes for the level measurement, it is basically 100% recorded. Number 3rd, there are no moving parts in this system is available. Number 4, it is suitable for continuous indication and or control of the level measurement. Number 5, it is good for use any different types of slurries, that is different types of materials. And probe materials, that is equipments of the system, it is for most corrosive fluids are available. That means when you have to measure any acidic type or alkali basis liquid, so there is a no losses or no corrosive, it is not done from this capacitive type of level measurement. Okay, and disadvantage it is also available, little bit disadvantage. Number 1, its sensitivity is adversely affected by changes in temperature. Changes in temperature. So, any temperature it is changes for the particular liquid you have to use, that is the high temperature or cold temperature. So, sensitivity it is basically changes. So, this is the basically disadvantage of the system. Number 2, measured fluid must have proper dielectric quality. Quality. And number third, probe length. Probe length and mounting must suit the tank. Okay, so this is the basically disadvantage for the capacity type of method. So its sensitivity is adversely affected by the changes in temperature. Number two, measured fluid must be have proper dielectric qualities also. And number third, probe length. That is a probe we have to use for the dielectric materials. So this probe length and mounting process it must be the tank also. So this is the little bit disadvantage are present in this method. So in our process control industries, we have to broadly use this for the indirect method for the capacitive level indicators. Another one is radiation. We have to discuss in our next class that is a radiation level detectors. Okay, so is it clear all of you? So everyone write your own name and roll number in the chat box also. And anyone, any doubt, so please ask me. And so नेक्स्ट वीक में आप लोगों को मतलब मिड सेम एग्जाम है सो बेस्ट ऑफ लक फॉर दिस एग्जाम सो अप टू द सिलेबस जितना कवर हो चुका है उसके ऊपर ही आप लोगों को क्वेश्चन मिलेगा ठीक है सो best of luck and those who have not present in previous classes and not follow the routinely class notes in Google Classroom, so please go through the Google Classroom portal and also you have to go through the YouTube channel that is the previous classes. So please everyone read this carefully. This is best for your best givens that is your mid-sem exam. Okay, so thanks everyone. Please everyone write your own name and roll number. And one screenshot, please. Yeah, Jatin, you have to take the one screenshot.